Okay, so in 5.1, we talked about probability distributions. We found out how to calculate the mean or expected value. We also talked about how to calculate the standard deviation. We also found out that there's a way to do this on a calculator. Okay, so this is kind of, in a nutshell, what we did on 5.1. So today we're going to move on from that, and we're going to do a specific kind of probability distribution. This probability distribution is called the binomial probability distribution. This is fairly important because in the grand scheme of things, we don't do a whole lot with the binomial distribution itself, but it is the gateway from us getting from a certain place to binomial, and then from there we go to a normal distribution. So we take a distribution, we take a sample from a population, and we say, well, this is a binomial distribution, but because it meets certain criteria, we can actually assume this is a normal distribution. Okay, remember I told you that the whole goal is to get to a normal distribution because there are so many things that we can infer, we can say, we can calculate once we make the assumption that it is a normal distribution. So this is the gateway to getting there. Okay? So in that sense, it's important. Okay? So if you flip the page, there's a definition there. There's a definition. Binomial probability distribution results from a procedure that meets these four requirements. Okay, so four requirements, or the mnemonics that you will use, is this: bins. Okay. First one being the B being it is binary, meaning you have only successes and failure. There are only two results here. Okay, it's either one or the other. You flip a coin, it's either a head or a tail, right? You roll the dice, there's a probability of getting like 1 through 6, but you can define success as rolling a 1, everything else a failure. Right? So you can make it a binomial distribution. Okay? So it has to be binary. There's a success or a failure. You win or you lose. You know, whatever. And then the I is that the probabilities are independent of each other. Okay, in other words, one result does not dictate or change what's going to happen on the next one. This usually means that you are doing this with or without replacement. With replacement, right? Because if you did it without replacement, the first result is going to dictate what happens on the next one, right? And they would not be independent of each other. Okay? All right, so this usually means that you're doing this with replacement. Okay? So they are independent. Then N, the number of trials are set. Number of trials are set. Okay? S, same probability for each trial. Okay, so these are the four things that need to happen. These four prerequisites need to be satisfied for you to be able to say it is a binomial distribution. Okay. Underneath there's a green box that says notation for binomial probability distributions. The only thing that's kind of interesting there is the P and the Q, and we've done this before. Okay, P, if the P is usually the probability for success, and then so failure would be 1 minus P, and then sometimes we put that as Q. Okay, 1 minus P, right? So if I define rolling a 1 as a success, the probability is 1/6, right? Because there's six sides, right? So failure would be 1 minus 1/6, which is 5/6, right? So 5/6 of the times you would fail, 1/6 of the time you would succeed. Okay. Okay, so then there's N, the fixed numbers of trials, and then X is the number of successes, whatever you call that success, right? P is the probability of success, Q is the probability of failure, so on and so forth. Okay, example number 1. When an adult is normally randomly selected with replacement, there is a 0.85 probability that this person knows what Twitter is. Okay. Suppose that we want to find the probability that exactly 3 of 5 randomly selected adults know what Twitter is. Okay. What is this? Does this procedure result in a binomial distribution? So, bins. Success is what? They know what Twitter is, right? Failure is they do not know what it is, right? Independent. Each one is independent, correct? Just because the guy in front of you knew what Twitter is doesn't mean that the next guy has nothing to do with the next guy, right? So they're independent. So that works. Are the number of trials set? Does it specifically tell you? What is the number of trials here? 5, right? Okay. Same probability for each person, correct? Right? There's no reason to believe that it wouldn't be. All right. So yes, it satisfies the bin. So this is a binomial distribution. Okay. All right. So blah, blah, blah. Treating dependent events as dependent. Uh-oh. When selecting a sample, as in a survey, we usually sample without replacement. So we actually do without replacement. Okay, but we've done this before. We said, remember when we had 10,000, I think it was USBs or something like that we were picking out, and we had like 20 that were bad, and we proved that sampling with replacement is just about the same as without replacement, right? And at that point we said, as long as you do not oversample, you do not sample more than 5%, okay, then you're okay. When sampling without replacement and the sample size is no more than 5% of the size of the population, you can treat these selections as being independent, even though technically they are dependent because you're sampling without replacement, okay? So you cannot oversample, oversampling being here 5%, okay? Okay, methods for finding binomial probability. So how do I actually find the probability? What is the probability if I knew that knowing Twitter was 0.85 and I was doing 5 trials and they wanted to know the probability that 3 of them knew Twitter? Okay? 5, choose 3, or 5 combination 3. Remember this? We did this. And then we have 3 successes. 3 successes, so to the third. 2 of them are going to be failures. 1 minus 0.85. So those are the 2 failures. 3 successes, 2 failures, and there are actually this many combinations of, right? You see what I'm saying here? So it could be success, success, fail, success, fail, or fail, fail, success, 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 or whatever. There's the combination. This is the combination here of choosing 3 out of the 5. The 3 successes out of the 5. Okay? So the way you would calculate this, it would be, you have to do this, so it would be 5 factorial, 3 factorial, 2 factorial, right? 3 factorial, and then the 5 minus 3 being 2 factorial, and then you would just cancel. You would actually do the 5 to the third, 0.15 to the second. You would just multiply it. Okay, and that's how you'd find the probability of getting 3 successes, having 3 people know what Twitter is out of the 5. Okay? Blah, blah, blah. And then there's using technology. Using technology. And the technology that they're bringing up here is not the technology that you have at your hand, so let's go ahead and bring your calculators out and see if we can do this. So you're looking for is stat calc, and you're looking for binom PDF. You find binom PDF? What's math probability then?
There's a random binom.
Yeah, random, what is it?
Random bin. That one?
No, that's not. Binom CDF. The green sheet.
I found it in the catalog.
In where?
Just in the catalog.
In the catalog?
Yeah. But it's close up to the top because it's search.
Binom PDF and CDF. Okay, let's see.
Second tier.
Wait, so what's the actually what's the 8.5? What's the those numbers? The 0.85 and the 0.15.
From the example, there's a 0.85 chance of it being right. So that's the.
Oh, so then
three
that's the
right?
leftover?
And then, yeah.
So you're still letting me
Because
guess.
the leftover
I don't
with the
care,
chance
I'm
of
over
it
it.
being wrong.
You have more
So it's-
wisdom than you're
okay,
capable.
one minor.
I want to prep, that's what prep is, I've been to prep. I've been at 3 classes.
Actually, no, we've lost.
I've been to prep.
Second bars, binom PDF.
Wait, hold on.
Second bars,
Oh.
Normal PDF?
binom.
Oh, it's all the way down.
Oh, there it is.
It's gonna be way down there. Oh, there it is.
Binom PDF?
Binom PDF. Binom PDF. And then what's the next one that it asks?
It's X list, Y list, frequency list, or right?
What?
You should be able to put 0.85 in there somewhere.
It says trials P X.
Trials will be what? 5. P would be 0.85. The number of successes would be 3.
Is that X value?
What's the X?
That's what I said though.
X value would be this, wouldn't it? Or is that the P value?
I thought it was LPP, wasn't it?
Normal?
Okay, so we're looking at two different things here.
Did he not say binom?
Your calculator's asking different things that her calculator's asking.
The X value is
No,
the number
no,
of
no.
successes.
If you
Okay,
hit
well then
CD.
that would be 0.85.
No.
No, probability.
Yeah, X value
Let
would
me
be
do
3.
it again.
Number of
Okay,
successes.
Oh, no, okay.
Your X value is 3.
Okay.
Okay, now it takes me there.
P,
Oh my gosh.
wait, X value, okay.
Trials is 5.
P is the
Trials is
P
five.
3.
P is the
X value.
X value
P is
is
0.85.
X value is 3.
Wait, why is it?
P is 0.85.
Okay.
Ace, 5.8.
It's P.
Everybody get the same value?
Oh,
What?
no, I did that.
Oh,
Point
I
one
did
three
get
eight.
that.
Point 138. Point 138. Everybody got it? We good? Okay.
Why is
So
it
that is the PDF. That means that the probability of actually getting 3. Okay. Now there's another thing in the second vars that says binom CDF. CDF meaning cumulative distribution function. So we put the same things in there. Okay, go ahead and click that one, and you should be able to put the same thing, put the same numbers in there. See what happens.
0.165.
You get 0.165, a different number. Okay, so what that is that it's cumulative. So it's adding 0 failures, 1 failures, 2, all the way up to 3. It's cumulative. You see what's happening there? So if I asked you, okay, so this is the setting, we have 5, we're doing 5 trials, and I ask you, what is the probability you're going to get at least 3 successes? What are you looking for? How would you find that? You would have to do the probability of 3 plus the probability of 4 plus the probability of 5, right? You would have to do 3 separate PDFs. Or you can calculate the CDF up to 2 and subtract that from 1. Does that make sense?
To find.
To find 3 or better.
Because
Because 0, 1, and 2 are not 3 or better, correct? So here's the probabilities. You have 0, 1, 2, 3, 4, 5. These are the 1, 2, 3, 4, 5, 6 things that can happen. I asked you, what is the probability you're going to get 3 or better? Right? So there's a probability that encompasses all of these 3. What I'm saying is that if you use the CDF function and do the cumulative between 0, 1, and 2, that gives you that value right off the bat. And then you just subtract that from 1 and you're done in one fell swoop. Rather than calculating 3, 4, and 5 and adding them together. No? I'm getting blank stares here.
you just use
think I
the
get it.
cumulative ones for 3, 4, and 5.
The cumulative for 3 is going to give you from here to 3. Cumulative to 4 is going to give you from here to 4. And then 0 to 5. You don't want that,
Okay.
right?
Okay.
Does that make sense?
Yeah.
Okay. All right. Okay, so the next one's going to be example number 3, overtime rule in football, and we will save that for tomorrow.